All right. Another equation that is given to us is here. We are to write, out, they ask us to write out all all the equations of uniform motion and prove that the motion of a uniformly accelerated car does not depend on time. All right. So the solution we are to just write out. So from equations of motion, we defined acceleration as the rate of change of velocity. All right. This equation simply means that if we make v the subject, we have u plus at. And this is referred to as the first equation of, motion. All right. First equation of motion, v equals u plus at, where v is final velocity, u is initial velocity, our a is acceleration, and t is time. So let's go to the second equation. Second equation says that displacement is equal to average velocity divided by 2 multiplied by time. All right. So this is the first part, all right? The first part. And then the second part, we're able to use first equation against this, and we can establish that our ut plus half at squared is equal to displacement. All right. So this is the real second equation of motion. All right. This is second equation of motion. And then the third equation of motion, v squared is equal to u squared plus 2as. So we have this as the third equation of motion. These are the three levels of motion, equations of motion, all right, respectively. Okay, and they have proof. We can also establish this. I told you the first time that if you use this against this, this is going to give us this. But our focus is not really on how to prove this. It just asks us to write out. We'll have to satisfy the needs of the question. So, but we ask at the second question that the car is uniformly accelerated. All right, we should show that it does not depend on time. Now, out of these three equations, this is the equation that does not depend on time because we don't have time here. And that is the one that will help us to establish that. So how can we prove this equation? So we are to show that our v squared is equal to squared plus 2as. I think that is very important. So there are two things we use, okay? From v equals a plus t, make t subject, you're going to have our t is equal to v minus u divided by a. All right? And displacement is equal to average velocity over 2, everything multiplied by time. So we bring this one in place of this, into this equation. If we do that, displacement is equal to v plus u over 2. Instead of writing this time down, you bring all of this in place of this time because we say time is equal to v minus u divided by a. So if we do that, we're going to have v minus u over a. So if we do this, that's going to be v plus u, all right? V plus u, this multiplied by this, and then v minus u. Then the denominators, 2 times a, that's going to give us 2a. If we cross multiply, the numerator appears to be like equation or an expression of difference of two squares. All right, so if we do that, we have 2as equals v squared. Open this bracket, and then you just simply write it as difference of two squares. If you have something like this, they are adding, multiplying, they are subtraction. All right, what you do is you just find the difference of two squares. You square one, take away the square of the other one. That's what it means. So make v squared subject. In other words, make it to stand alone at one side of the equation. So we take minus u squared to the other side. What it means is when this minus crosses equality sign, it becomes positive. So we have u squared plus 2as equals v squared, which simply means that our v squared is equal to u squared plus 2as. And that gives us the third equation that they want us, that is not time dependent, as a requirement for the question. Hope you learned something.